Welcome to Actuaries Changing to Thrive, a short video series presented by Deloitte Consulting. In each episode, we would like to bring you new perspective of future insurance trends and how fast-changing technologies bring positive impact to your business in digital transformation journeys. I'm Chris Tam, an Actuary Director in Deloitte Consulting. Today, I've got Dr. Paul Sim with me, who is the lead FinTech partner in Deloitte Consulting as well. Paul is a well-recognized expert in AI and blockchain. We are very happy to have Paul today.
Thank you.
Yep. In Hong Kong, we know that we have more stringent requirements in enterprise risk management, which is ERM, which arise a lot of discussions of how AI and technologies can apply to the risk assessment process. So to start with, Paul, can you share with us some experience on how AI machine learning can be applied in financial institutions?
In the past, in financial services, we use a lot of statistical model and statistical analysis. The idea is to find out the relationship between the independent variables and the dependent variables and the cause and the effect relationship. However, these models need human intervention from time to time to make sure that they are picking up the right signal from the market. With AI and machine learning engine, those new technology can actually pick up the new variables that are relevant to the effect automatically. But there is a catch. If you want to use AI engine, you need to make sure that the feedback loop is there. So I can give you an example. In the past, if we invest with an IT system, we will call that an algo trade or quant trade engine, which will embed a statistical model, and then the data scientists will keep tuning the model. But with mobile advisors that use really machine learning engine, it will take up the return resulted from the investment decision made by the engine and automatically tune the engine by itself. So this is a good example of how AI is different from the traditional statistical applications. And we use this in a lot of predictive analytics applications. So I want to predict the customer's propensity to uptake a product, or I want to predict the risk of certain product. Those can be AI use cases. Secondly, there are a lot of natural language processing engines that are using AI. So when the translation or when the understanding of the human speech is not accurate, we can give the engine feedback and the engine will learn over time. Lastly is computer vision. So a lot of like facial recognition or object tracking is now using AI engine. So all these are good use cases of AI applications.
Thanks, Paul. It seems that one key success factor is to set up a feedback mechanism for the machine to learn from users. It is not difficult to think of situations of how AI machine learning can support risk identification process. From a market risk perspective, AI can learn from the business users and the risk manager of how to identify market data which have high likelihood of unfavorable market condition and trigger alert. On the other hand, from a reputational risk point of view, AI can automate the screening of the negative headlines and news so as to trigger alert for the management to take timely mitigation actions.
On that point, I can give you some concrete examples. So in the past, if we want to predict market risk, we may digest a lot of market data feed and news, etc. But now we see engines that actually process the tweets from political leaders in order to predict any macroeconomic impact and any market risk as a result. There are also engines that pass through the data in social media. So if some customer is complaining about the company in social media, there will be an alert automatically created by AI engine for the enterprise to react. So these are some real examples which can illustrate how AI is helping.
Thanks, Paul. As an actuary, I'm actually a big fan of statistical model. So Paul, can you share with us some insight of how AI can add value against a traditional statistical model?
Sure. So in the past, when we build statistical model, we try to limit the number of independent variables so that we are not doing data fishing and dilute the effect size. With AI, we can actually process big data, meaning large volume, high velocity, high variety kind of data. And over 10,000s of variables, we can pick up those that are relevant to the effect. So this is one power of AI. Second is that, as we mentioned earlier on, machine learning can learn from the feedback. That means if there is some trend in the market or some change in the demographic of the customer, we can pick it up automatically. Lastly, in the past, statistical model will have limited predictive power because we always ask for an error level less than 5% or 10%. AI does not work like that. When the data quality may be as low as 45%, you can still make a pretty good, like 70% accurate prediction. That is the power of the AI neural network. And with that, we can already make certain business decisions with certain confidence. So this is why in many use cases, AI is preferred rather than statistical models.
Thanks, Paul. It is really interesting to know that the data need not to be 100% accurate and perfect in order for AI to predict effectively. However, I also feel like that AI work today doesn't mean it will work tomorrow because the company risk profile and the market condition can evolve. So, Paul, do you have any suggestion on how we could deal with this situation? And would there be any other limitation in AI that we need to be aware of?
Sure. So as we discussed, machine learning can pick up new trends in the market. However, it is not something that happens overnight. If the model has been feeding on 10 years of data and already built certain relationship among the variables, it may take equally long time to forget what it has already learned. So this is something practitioners should be aware of. Secondly, the model is actually not transparent. A lot of knowledge is embedded in a complex neural network. So if you use AI engine to produce regulatory report, you may find it difficult to explain to the regulator how you make those predictions. That's why it is only used for marketing or risk rather than regulatory reporting or compliance purpose.
Thanks, Paul. It seems that timely calibration of the AI is necessary. In specific, company should tune the AI responsiveness against the bad swarm event in order for the AI to avoid the over-reliance of the past data that has been accumulated over a long period of time. So, Paul, thanks for sharing with us a lot of insights and also tips. To end this episode, it would be great if you can give us a few key takeaways.
Sure. So first of all, the key difference between statistical application and AI is that AI got a feedback loop, and then you can learn over time. We know that the best use cases for AI would be marketing and customer propensity, risk management, and anything that are not really compliance related. Lastly, as you mentioned, recalibration is important. So regular review of the model, make sure it does not be biased, and when it is out of date or the model need to be relearned, then we need to innovate regularly.
Thanks, Paul. Thanks everyone for watching this video. We hope that what we have shared can give you some insights on how AI can apply to enterprise risk management. See you in the next episode.
Thank
Bye.
you.